My name is Nti Fafa Abete. I'm an assistant professor and soil and nutrient management specialist at University of Tennessee. I'm located at the West Tennessee Research and Education Center. Thank you for joining me this morning virtual training. I will be talking on soil sampling and testing consideration for Optimum 12 yield. Soil fertility is a significant crop input for most row crop producers, and it represents about 13 to 20% of the total production budget. Given the substantial investment, it is very important to generate quality soil fertility information. And the best way to generate this information is through a robust soil testing program. Soil testing is very important, and I look at it from the standpoint of the 3 Ps. Soil testing can increase productivity, it can contribute to profitability, and also provide some protection to the environment. When we test our soil, it tells us input the current nutrient supplying capacity of that soil. And in doing so, we are able to identify as well as correct any type of deficiency that may be in that field. We are also able to identify any kind of nutrient variability that may exist in the field. And we are able to deploy our resources in appropriate location to maximize our yield. All of these will contribute to that productivity I mentioned, and with increased productivity, we are likely to have increased profitability or increase our profit margin, because we'll also cut down on fertilizer costs, which has been the case in most research. Also, we also will reduce environmental risk when appropriate nutrients are applied at the appropriate time, and also help reduce environmental risk. So soil testing is a multiple step process that begins with collecting a soil sample that adequately represents the field that is being tested. And once the soil gets to the lab, the next step is to estimate the potential plant available nutrients in that soil, or soil analysis. And then the third step, which is our interpretation, is pretty much we want to predict the probability of obtaining a profitable crop response to the line of fertilizer. And then the fourth and final step is just to recommend how much of that line of fertilizer do we have to put out. So the first step is what I'll talk about this morning, that is soil sample. And soil sampling is very important and crucial because once it's compromised, the reliability of your test would also be compromised. So we have to spend quality time to come up with a good soil sampling method, depth, time. It's very important. Once that sample is bad, your result would also be faulty. An important factor that is worthy of consideration is this in a soil testing program is the choice of the soil testing lab. Is it okay to send samples to just any soil testing lab as long as it's certified? My recommendation is that if possible, try to use a regional soil testing lab, which will be familiar with your local soil conditions, because different soil test labs have different sampling procedures, extraction method. It's very important to get one that is local, where you can have consistent results, or you can compare the results you get from that lab to other labs within that same region. First, let's talk about when to sample. So soil test values vary across seasons. If you look at properties like soil pH, soil test K, soil test P, these are greatly affected by seasonal fluctuations. And these fluctuations or variations are driven by nutrient uptake. It's also due to mineralization, breakdown of organic matter or plant residue, as well as environmental factors like rainfall. So the graph you see here shows the pH of a soil collected at 0 to 6 inch over several months. On the y-axis, you have the soil pH, and then on the y-axis, you have the sampling time. And what you realize is that the soil pH in the spring is about 0.2 units higher than in the fall. The trend is the general trend. The general trend you see is that there is a gradual decrease all the way to summer where you have your least soil pH, and then it picks up again in the fall. So that is the general trend. However, in Turkey, a study that was done showed that your soil pH can increase linearly and not necessarily decrease. That is an observation. We also want to keep in mind that our soil test value can vary depending on how soon you collect your soil sample after harvest. Generally, if your soil test numbers, generally your soil test numbers tend to be lower just after harvest compared to 6 weeks after, because residues break down and release K. Also, clay mineralogy could affect the potassium levels in the soil. Freezing and thawing, these are factors that can affect the availability of some soil test measurements. So soil samples can be collected any time of the year, although September to November or March to April are the best times. There will be some differences as I indicated in previous slide. Spring soil sampling gives a more accurate picture of the available plant nutrient, but sampling in the spring leaves no room for error. For instance, if you have a wet spring, you can easily be backed up. You may end up forfeiting or not uh, following recommended soil fertility, following all the soil fertility recommendations. So generally, it's best to sample months ahead of planting to allow for planning and also getting prices online and fertilizer. Fall is highly recommended if you are able to, but it is important to be consistent as much as possible with the sampling time from year to year. If you decide to soil test in the spring, try as much as possible to do it every spring and not spring or fall. And if possible, use the same lab for your analysis every year. So how often you collect your soil test depends on several factors like cropping intensity, your tillage method, as well as weather. Generally, with an intense cropping management like double cropping, you will collect samples much more frequently every other year as compared to a row crop that is being grown on a conventional field that will be every 3 years. Also, if you have high value cash crop, it's very important to sample these fields annually because this crop take up a lot of that nutrient. Also, if you suspect any kind of nutrient deficiency problem, either through tissue sampling or visual diagnosis, it's a good time to test the soil. So what depth should the samples be taken? So soil samples used for nutrient recommendation should be taken at the same depth each sampling time. And what I mean by that is that you don't want to collect soil samples from 0 to 4 at one part of the field and then move to another part of the field and collect 0 to 6. You want to be as consistent as possible. The reason being that our recommendations or interpretation as well as recommendations, they are based on soil samples collected from a specific depth. So if it, in the case of Tennessee, it's 0 to 6 inches, and that is what research has shown to be cost effective. So that is what we recommend. Bear in mind that soil samples based on shallower depth tend to have higher soil test value. So you may have lower soil fertility recommendations. It's important to note that. Also, the general trend is that as you collect soil samples from a deeper depth, the soil test value tend to decrease. So the soil test value at 0 to 4 inch is generally higher than the 0 to 8 depth, inch depth. And as deeper as you go, the more fertilizer you might need because of reduced soil test values. I mentioned representative sample, and this is very important because of the variations in physical and chemical properties in the soil. And it's very important to develop some kind of systematic type of sampling to assess, to adequately or accurately assess your soil fertility. There are three main methods of sampling: the whole field, the grade, and the zone method. I will go through these in a little more details in subsequent slides. And the choice of this sampling method depends on cost. You should also consider sampling history. If this is a new field or a newly purchased field or a newly rented field that has never been found, it will be good to, or I recommend a grade sampling method, or whatever proposed fertility management you want to use. For instance, if you want to variable rate apply your fertilizer in line, it might favor to have a grade soil sampling rather than a whole field sampling. Also, if your soil test levels in the field, if you look at previous soil test levels, if they are a little bit low, you might want to stay away from whole field approach and then focus on a grade sample, because with lower soil test levels, you may have significant or huge differences in fertilizer recommendation. Okay, let's talk about each individual sampling method. So the first method we'll talk about is the composite or the whole field approach. This is typically the conventional sampling method. It's been there for forever. And what happens is that your fertilizer recommendations are based on the averages of all the samples that is collected. On the plus side, this method is relatively cheap because you collect very few samples and you spend way less time doing that. But on the minus, it doesn't provide a whole lot of information on nutrient variability. With whole fields, it's recommended that you collect at least one sample per 10-acre field. In Tennessee, that is the recommendation. And within each sample point, you need to collect at least 15 sub-samples. One other thing to take care of is making sure that you don't collect samples from unusual areas. You want to avoid collecting samples from unusual areas. So an example of an unusual area would just be an area where you've had lime or manure piled up over the years or some time ago. Um, it would show up in the soil test results, so you want to avoid that. Also, you want to avoid rows where fertilizer has been abandoned, and you also want to stay away from low spots in the field. However, if these fields are large enough, then you might want to sample these areas separately. In the diagram that you see, it's a 90-acre field. The minimum number of samples you can collect from this field is 9. And at each sampling point represented by this dot, you're supposed to collect somewhere between 15 to 20 subsamples, and you have to collect it in a zigzag pattern. Now, the next sampling method is the grade sampling. And this method works well for variable rate application of fertilizer and lime. It's the most expensive soil sampling method, but the good thing is that it helps detect whatever variability or nutrient variability that might be in your soil. So it's very good. Here is a very good example of a grade sampling where the field is divided into approximately equal squares. The sample in each block will consist of 8 cores taken within 60-foot radius of the sampling point. The location of the sampling point within each block defines the type of grade sampling. So you have the square where you take the sample right in the middle. You have the diamond approach where it's not right in the middle, but shifts a little bit closer to the side of the grid, where you have that diamond shape. And then the third method or grid method is the non-aligned. I personally recommend diamond and the non-aligned method. And the reason being that if you look in your field, a lot of the activities that goes on there is mainly linear features. You are driving tractors back and forth. So non-alignment or the diamond typically helps capture the variability. And the final method, sampling method, is the zone management approach, which is just a hybrid of the whole field or the composite sample approach and the grade sampling method. It's pretty much cost effective because you are combining both approaches. Pretty much cost effective. Generally, you want to create zones based on knowledge of the field. You want to look at soil type, you want to look at yield map, you want to look at soil management in the past. So if you look at this diagram, field 1, 2, and 3 might be low-lying areas, but then you manage these areas under different nutrient management. Field 3 probably had manure, so when you're sampling, you have to sample it separately. If you look at field A and B, these are gentle slopes, sloping area, but then perhaps field B received line, but field A did not. So when you're sampling, you want to break it into that zone. That is what the management uh, zone is all about. The zone management approach is all about. And these are some of the tools available to collect soil samples. There are way array, there's wide array of sampling equipment which is available. Look at ATV mounted hydraulic um, probes or augers. These are all tools that can be used. Drill bits, augers, Newton probe. Thank you. And if you have any question or comment, you can send it to the contact provided. Have a great day.